Now, determinants continue. For example, compute. One. We can expand by third column because it contains 0 and 1. We use this number 1 to transform this element into 0. Okay. Expand by column, transform by rows. Okay. We transform row which contain this element, row 1. Row 1 becomes 2, row 1. We use row 3. Row 3 which contain this number. 3, 1 plus what? I want 0 here. So this number is minus 3. Okay, minus 3. 3 minus 3 of 1 is 0. Now we write row by rows. Row 1 minus 3, row 3. 1 minus 3 of this, and 2 minus 3 of this, minus 10. 3 minus 3 by 1, 0. Okay. 1 minus 3 of minus 3, 10. 2 minus 3 of 4, minus 10. 3 minus 3 of 1, 0. Rewrite this row. Rewrite this row. We transform row 1 using row 3. Okay. And now we expand by third column. We write this element, number of minus sign, minus 1, row 3, row first, plus column 3. Okay, row 3, column 3. Delete row 3, column 3. We have 10, minus 10, 2, 1. Delete. Delete rows of this element and columns of this element we have here. So 6 minus sign is plus. Main diagonal pair, sub-diagonal minus plus 20. So we have the result is 30. Okay. We expand by the column which contains 0, 1. And we use 1 to transform 3 into 0. Then we expand by per column. Write down this element, number minus sign, row 3, column 3. Delete row 3, column 3. We have. Okay. We can expand by rows or by column. Expand by row, transform columns. Expand by column, transform rows. Another example. Order 4. We have factorial 4 equals 24 terms. Very, very complex. Okay. Now we choose the row which contains 0 and 1, 0. We use this element 1 to transform 4 into 0 and transform minus 2 into 0. Equals. Expand by rows, transform by column. Column 1. Becomes 2, column 1, use column 2, which contain 1. Minus 4, column 2. 4 minus 4, this is 0. Okay. And we transform column 4, C4, becomes 2, column 4, use column 2. Use column 2 plus 2 minus 2 plus 2 of 1 is 0. Expand by rows, transform by column, and use the column which contain 1. Transform column 1, 4 minus 4 is 0. 2 minus 4 of this minus 10. Okay, 2 minus 4 of this minus 4, 2 minus 4 of this minus 6 and 1 minus 4 by minus 4, 17. Okay. Rewrite column 2, 1, 3, 1 minus 4. Rewrite column 3, 0, 1, 3, 2. And transform column 4. This formula. This number plus 2 of this number 0. This number of column 4 plus 2 this number 7. 2 times 3. 5 column 4 plus 2 of this 7. Okay. 6 column 4 plus 2 minus 2. Okay. Plus 2. Now we expand by row 1. Write down this element and number minus sign. Position of this element, row 1, row first, column 2, column plus, and delete row 1, delete column 2 with content of this element. We have minus 10, 1, 7, minus 6, 3, 7, 11, 17, 2, minus 2, etc. Okay, we reduce the order of element of determinant from 4 to 3. One determinant of order 4 become to one determinant of order 3. Okay. Now, Laplace expansion. Laplace, pronounced in French, Laplace. Expand by ith row. Ith row. A, I, row I, column 1, A, I, 2, etc. A, I, N, column. Determinant of A equals this element A, I, 1. Number of minus sign I plus A, row, then column plus, and minor I1, minor deleting ith row and j column. Deleting ith row and one column. We denote mi1 minor. Okay. And plus this element, write down AI2 number minus sign. We write minus 1 instead of minus. Row I plus column 2 and deleting I row second column. We use this symbol Mi2, etc. Here this element write down A, I, N. Number minus sign I plus N. Okay, and delete I row and N column. We use this symbol MIN. Element number minus sign and the minor deleted delete it. Okay, delete. The row and the column which contain each element. Equal sigma A I K from 1 to etc. N K from 1 to N, and we use this symbol Cij, number minus sign I plus J and M Ij. Deleting row, column, and before we have the number of minus sign cofactor. Okay, M deleted, I row deleted, J column, cofactor before we have the number minus sign. C I K. Okay, element, number minus sign, and minus, delete. Now expand by J column. Similarly, expand by J column. J column. A row 1 column J, A row 2 column J, etc. A row N column J. We have determinant of A equals sigma A 1J, 2J, Nj. We write K, J, C, K, J, K from 1, 2, 3, etc. N. Okay. Each element on J column and the number minus sign of this of that element, and delete. Okay. Now we consider about from properties of determinants. Number 1, determinant of A equals determinant of transpose of A. Transpose. Row becomes to column. It's called AT, transfer. For example, 2, 1, minus 1, 3. The main diagonal 6 minus the sub-diagonal plus 1, 7. Now, transpose of this is first row becomes to first column. Second row becomes to second column. And we have 6 plus 1, 7. So for determinants, we can transform rows or columns. Row, column. Okay. For determinants, we can transform row and column. Since determinant of A equals determinant of transpose of A. Okay. And number 2, if B is obtained from A by exchange to rows or columns, exchange or to column. Row I exchange to row J or column I exchange with column J. Then that B equals negative of that A. Not equals after the signs. For example, 3, 1, 4, minus 1, 0, 6, 2, 5, minus 3. Now we can use the pocket calculator to find this. Mode for matrix. Define matrix. Number 1 map A. Number of rows 3. Number of columns 3. We enter each element from the left to the right, from above to below. 3 equals 1 equals 4 equals minus 1 equals 0 equals 6 equals 2 equals 5 equals minus 3 equals, and press AC button to save. Then we use the button option and in menu determinant number 2. Press 2 and option must A. Option number 3 must A. On your screen you have that must A equals minus 101. Okay. Now we exchange two columns. Column 1 becomes to column 3. 3 minus 1, 2, 4, 6. 4, 6 minus 3. And remain column 2. Now option. Define matrix number 1. 2 must be number of rows 3, number of columns 3, and chase element from the left to the right. 3 equals 1 equals 4 equals minus 1 equals 0 equals 6 equals 2 equals 5 equals minus 3 equals, and say AC. And hit solid. Option. Define matrix. Number 1 must see 3. Number of rows here, not here. 3. Number of columns 3. 4 equals 1 equals 3 equals 6 equals 0 equals minus 1 equals minus 3 equals 5 equals 2 equals AC. Option. Number 2 determinant. Option. Number 3 sub. Number option must see number 5. Must see is this. Option. Number 2 determinant. Option. Number 5 must see equals 1, 0, 1. Alter the sign. Okay. If we exchange to rows or to columns, the result is altered the sign. Minus becomes 2 plus. Now consider example. Given A of order 4 and B from A, B is changed from A by A row 1 we denote A subscript A1, row 2 A2, row 3 A3, row 4 A4. Okay, subscript B is obtained from A by move this row to this, move this row to this, and move row 3 to this, and move this row. Okay. The question is determinant of B equals determinant of A. Okay. This is the question. B is obtained from A. As follows. Now we start with A. A1, A2, A3, A4. We transform by exchanging 2 rows, step by step, step by step. A2, A1, A3, A4. Okay, exchange 2 rows. And we have here. Okay. Now we exchange 2 rows. We write A2, A1, exchange A4, A3. Okay. The same. And move here, rewrite A1, A2 here, and A3 here, and this is B. Okay, we exchange two rows step by step, and we start from A, transform to into B. So we have three times of exchanging two rows. So 3 minus sign 3, and the result is determinant of B minus determinant of A. Okay, we exchange two rows step by step from A to B. Now, property 3. If B is obtained from A, by multiplying one row or column from the property 1 row or column, and by K, multiplying by K into one row or column, and determinant of B equals K determinant of A. Okay? Okay. Multiplying 1. For example, the main diagonal 6 minus of minus plus 6 back. Now we multiply the second column by 3, for example. 3 of this, 3 of this. We have 18 minus of minus plus 18. So this result is 3 times of this, because we multiply second row by 3, and the result is 3 of this. For example, we have to compute this. We check common factor of second column. 6. 1, 3, rewrite. 6 minus 1, 3. Okay. Common factor of one column, not of entire matrix. And we have 3 plus 3 is. Okay. For determinants, we check common factor of one row or one column, not of entire the matrix. One row. Okay. For example, A 4 times 4 a square matrix 4 times 1. 4 times 4. So determinant of 2a equals to what? Determinant of a. And here 2 multiply a matrix by 2. We multiply all elements of A by 2. But check common factor of determinant. Each column or each row, we have 4 rows. Okay. Common factor first row 2. And common factor of second row 3, row 4, then 2a becomes 2a. Okay. Check common factor of each row, not an entire the matrix, not entire matrix. So we have 16 determinant of A, 4 rows. Now property number 4. If one row or column 1 of A is a multiple of another row or column, and one row is multiple of another row. For example, row 3 is a multiple to row 1, or row 4 equals row 1 multiple. Then determinant of A is 0. For example, okay, consider this. Now we check common factor of row 3. Common factor is -3. One row, not entire the matrix. Rewrite, and -3, 1, -3, 2, -3, 3. Okay. And we have the same, identical. Now we exchange 2 rows. Rewrite common factor. Row 3 becomes to row 1. Row 3 exchange to row 1. Rewrite row 2. Row 1 becomes to row 3. And from above properties we have minus. Okay, if we exchange 2 rows, the result is out the sign. But this is the same as this. So, okay. equals minus x 0. Later, if you see this, you can write directly 0. Not wrong. Now, property number 5. If B is obtained from A by adding a multiple of a row or column, adding a multiple of rows or a multiple of column into another row, row I plus k row j, adding a multiple of one row into another row or column. Then determinant is not changed. Determinant of B equals the determinant of A. Okay. It's very important to find determinant, to transform element become to 0. Do not change the result. Now, property number 6. Determinant of A times B equals the product of determinant. For example, given A 4 times 4 and B 4 times 4. Determinant of A is 3. Determinant of B is 2. The question is determinant of 2A B inverse is what? Okay. A 4 by 4, B 4 by 4, determinant of A 3, determinant of B 2. So determinant of 2A multiplied by B square, B inverse equals what? First, we use this property to separate the symbol. Separate. Okay. First, 2A. Second, B inverse. Now, A 4 rows. We check common factor each row. We have 4 rows. Row 1, row 2, row 3, row 4. We have 4, 2. And it comes to determinant of A. Now, we have the determinant of inverse. We start with the definition of inverse. We have B, determinant, B, inverse of B. Definition equals I. Okay. And use these properties to separate the sign of multiplication. B inverse. Okay. Definition B inverse of B equals I. Determinant, and separate this symbol here. So equals determinant of I over, this is a number we can move, multiplying become to division. Okay, and you will see determinant of identity matrix is 1. I see this later and rewrite this and 1 over 2. Now, this 2A times B inverse equals 16 determinant of A times here 1 over 2. Okay, we can separate the symbol of multiplication of two matrices in determinant. Separate. Now, properties 7. If A is triangle matrix, then determinant of A is product of its element on the main diagonal. Triangle matrix, upper or lower, and determinant of its product of all elements on the main diagonal. For example, square matrix, upper triangle, upper. Okay, upper. From these properties, we have the result 2 on the main diagonal multiplied by -3 multiplied by 6 and 8. 1. you see, you know, we can expand by the first row. We have 2, this element, 0, and number minus sign of this, row 1, column 1, and is minor, deleting row 1, column 1. We have minus 3, 4, 5, 0, 6, 1, 0, 0, 8. This element, number of minus sign and minus delete here. Continue. To expand by the first column, we have this element minus 3. Number minus sign of this element, row 1, column 1, 2 minus sign is plus and minor 6, 1, 0, 8. Okay, expand by the first row, the first column. Continue. 2 minus 3. Sorry, 1, 1. And now expand by the first column. We have this 6 and number minus sign of this, row 1, column 1, 2, 2 minus, and okay, so we have 2 minus 3, 6, 8. Okay, later if you see this, you can write directly, not rule. Product of each element on each element on the main diagonal. Now we can use determinant to find inverse matrix if possible. We call that A is non-singular or invertible. If and only if determinant of A different from 0. If and only if and inverse of A is defined by 1 over that A different from 0, we can divide, okay, and adjoint of A, where adjoint of A equals C cofactor IJ transpose, okay. Review Cij, number of minus sign and minor deleted I row J column. Okay. A square matrix invertible, determinant different from 0, and this formula we can use this to find inverse 1 over determinant H1 of A, H1 Cij transpose. For example, find inverse of A if possible. Where A 1 minus 2, 3 minus 3, 4 square matrix. First we have to find its determinant. That A main diagonal 1 times 4 is 4. Sub-diagonal 2 minus sign is plus, but minus or plus minus 6, different from 0. Okay. Now C11 cofactor of this 1 is number sign minus sign 1 plus 1. 1 plus 1 number minus sign of this position. Delete first row, first column we have, and 2 minus is plus 4. Okay. C12 number minus sign 1 plus 2. 1, 2 here. Minus, delete row 1, column 2. We have here. This is not absolute value. Is equals itself. 3 minus is minus. Minus itself minus 3. And C21 number minus sign 2 plus 1. Delete row 2, column 1. Delete. We have. And 3 minus is minus. Itself minus 2. And C22 number minus sign 2 plus 2. Delete row 2, column 2 we have 1 equals 1. So A has 4 cofactors. 4 cofactors. And H1 of A cofactor Cij transpose. C11 4. C12 row 1 column 2 3. C21 row 2 column 1 2 and 1. Transpose. We write row 1 in column 1. Row 2 in column 2. And finally we have inverse of A equals 1 over its determinant and its adjoint here 4, 2, 3, 1. inverse of A. Generally, we have A, B, C, D, order 2. A is invertible. If and only if and inverse of A 1 over determinant AD minus BC main diagonal minus sub diagonal and here you can do the same. Okay, that's all for today. Thank you.